CRD, complete randomized design. In here, treatments are assigned to experimental units completely randomly, and CRD is used when the experimental units are homogeneous. Homogeneous experimental units are experimental units that are uniform as possible on all characteristics that could affect the response. In next slide, I'm going to talk about how to identify CRD. CRD problems have only one independent variable and one dependent variable. Please remember that CRD problems have only one independent variable and one dependent variable. For example, fertilizer level and yield. In here, our independent variable is fertilizer level and our response variable is yield. For another example, variety and yield. In here, our independent variable is variety and our dependent variable is the yield. CRD problems do not contain information about blocking factors. Next, I am going to show you a problem. An experiment was conducted to study the performance of 5 tomato varieties in a greenhouse. Tomato varieties were assigned experimental units randomly. The experiment contained 25 plots and yield values recorded from each plot are given below. In here, what are our treatments? Our treatments are tomato varieties, and our dependent variable is yield. What are the treatments? Treatments are the different conditions that are investigated in an experiment. In here, our treatments are tomato varieties. The number in bracket represents the variety number. In here we have 5 tomato varieties. Tomato variety 1, 2, 3, 4 and 5. And we have 25 plots. 25 plots. Single plot. One plot means it is an experimental unit. One plot is an experimental unit. Therefore, we have 25 experimental units. In next slide, I am going to discuss about homogeneous experimental units in depth. In here, our independent variable is tomato variety and our dependent variable is yield. Other than tomato varieties, many factors affect the yield of the tomato. Some of them are light intensity, amount of fertilizer, amount of water and the location. If we provide same light intensity, same amount of fertilizer, same amount of water and same location for all 25 plots, they become homogeneous because they are provided same environmental conditions. That means they are homogeneous. Next, I am going to solve this problem step by step. In step 1, we should write summary of figures. That means the information that are given in the problems. Total number of experimentals are 25 because we have 25 plots. Number of treatments is equal to 5 because we have 5 varieties, and number of replicates for each treatment is 5 because we have 25 plots and 5 varieties. 25 divided by 5 is equal to 5. In step 2, we should write the objective of the study. In here, our objective is to find out the best yield in tomato variety out of tested 5 varieties. You can find out the objective from the problem in here. An experiment was conducted to study the performance of 5 tomato varieties in a greenhouse. The performance means we should find out the best yielding tomato variety. Then we should write the statistical design. In here we use complete randomized design. In step 4, you should write the null and alternative hypothesis. According to this problem, our null hypothesis, there is no significant difference among 5 tested tomato varieties in terms of population mean tomato yield. And our alternative hypothesis, at least one variety is significantly different from other 4 tested tomato varieties in terms of population mean tomato yield. You can use this same structure for every CRD problem, but you should adjust the statement according to the problems. For example, if we conduct an experiment to study the effect of 5 fertilizer levels on the yield of tomato plants, we can write our null hypothesis as there is no significant difference among 5 tested fertilizer levels in terms of population mean tomato yield, and our alternative will be at least one fertilizer level is significantly different from other 4 tested fertilizer levels in terms of population mean yield. Different example than this one is if we conduct an experiment to study the effect of 4 hormones on the growth rate of paddy, we can write our null hypothesis as there is no significant difference among 4 tested hormones in terms of population mean growth rate of paddy, and our alternative will be at least one hormone is significantly different from other 4 tested hormones in terms of population mean growth rate of paddy. Like that you can adjust your statement, but you can use the same structure for every CRD problem. Next, you should outline the ANOVA table. It contains 5 columns and 3 rows. Like that you can outline your ANOVA table. Next, we are going to fill the ANOVA table. First, we should fill the degrees of freedom column. At first, we should calculate degrees of freedom of the treatment. Treatment degrees of freedom is equal to number of treatment minus 1. We have 5 treatments. 5 minus 1 is equal to 4. And the total degrees of freedom equal to total number of observation minus 1. We have 25 observation minus 1 is equal to 24. Degrees of freedom of error is equal to total degrees of freedom minus degrees of freedom of treatment. 24 minus 4 is equal to 20. Like that you can fill degrees of freedom column as follows. Then we should calculate treatment sums of scores. Before using this equation, first we have to find out the total yield of particular treatment separately. For tomato variety 1, our total yield is 8.8, for tomato variety 2 is 10.9, and for tomato variety 3 is 12.5, tomato variety 4 4.7, tomato variety 5 14.1. We can calculate total yield for a particular treatment as follows. For tomato variety 1, 1.9 plus and 1.5 plus and 1.6 plus and 2.1 plus and 1.7. It is equal to 8.8. Like that you should calculate total yield for all 5 tomato varieties. Then we can substitute a value for this equation. To obtain the value for this part, you should add squared value of the total yield of each tomato variety together, and it should be divided by number of observation per treatment, NT, 25 divided by 5. So you can obtain a value for this part as like that. Then to obtain value for this part of the equation, you should add all yield values of 25 plots together, and it should be divided by number of observation, that is equal to 25. In here 8.8 is the total yield of treatment 1, and 10.9 is the total yield value of treatment 2, 12.5 is for treatment 3, 4.7 is for treatment 4, and 14.1 is for treatment 5. The total value of these numbers equal to total value of yield value of 25 plots. So you can substitute your values for this equation and take the answer. To the next, we should find out the total sums of its cost. So we can use this equation to find out that value. For this part, you should add squared value of yield of each experimental units together, like that, and it should this for this part of the equation we can use our previously calculated value, that means 104.04. okay, we previously calculated the value for this part. To obtain value for this part, we can enter data in our calculator as follows: 2.4 squared plus 2.9 squared plus 2.3 squared plus 2.3 squared, like that. You should add all squared values of 25 plots together. And to the next, we should find out the error sums of its cost. Error sums of its cost equal to total sums of its cost minus treatment sums of its cost. Our total sums of its cost is 11.32, and treatment sums of its cost is equal to 10.64. 11.32 minus 10.64 is equal to 0.68. So like that you can fill this column. To the next, we should find out the treatment mean score and error mean score. To calculate treatment sum of score, we can use this equation. To calculate treatment mean score, we can use this equation. Treatment mean score equals to treatment sums of score divided by treatment degrees of freedom. Our treatment sums of score is 10.64, and treatment degrees of freedom is 4, and value is 2.66, and error mean score is equal to error sums of scores divided by error degrees of freedom. Our error sums of score is 0.68, and error degrees of freedom is 20, and our value is 0.034. Next, we should calculate test value. Test value is equal to treatment mean score divided by error mean score, 2.66 divided by 0.034, and it is equal to 78.24. To the next, we should find out the F critical value, and our alpha value is 0.05. Alpha means level of significance, and in here we should use F table to obtain F critical value. We always use treatment degrees of freedom as numerator degrees of freedom. Please remember that is very important. We always use treatment degrees of freedom as numerator degrees of freedom, and error degrees of freedom as denominator degrees of freedom. Therefore, our numerator degrees of freedom is equal to 4, and our denominator degrees of freedom is equal to 20. This is our F table. Before finding critical value, first we should look at the alpha value of F table. We should use appropriate F table to get the critical value. In here our alpha value is 0.05, and our F distribution also has 0.05 alpha value, and our numerator degrees of freedom is 4 and our denominator degrees of freedom is 20, and our critical value is 2.8661. So our critical value is 2.87. Next, you should graphically represent the conclusion. Therefore, you should draw a graph like that. In here, our critical value is 2.87. The values that are greater than 2.87 are in the rejection area, and our test value is 78.24. That is located in the rejection area, and you should draw this graph and mark these values, and also you should mark the non-rejection area and rejection area. That is very important. Then we can state our conclusion as if test value is greater than F table value, the null hypothesis can be rejected. Yeah, this is very important. You should write this statement, and it is essential. In step 12, we interpret our results. As our null hypothesis is rejected, we can accept our alternative hypothesis. Therefore, in interpretation part, you should write your alternative hypothesis. According to this problem, our alternative hypothesis is at least one variety is significantly different from other 4 tested tomato varieties in terms of population mean yield. So that is end of the lesson. Thank you for watching this video. If you like this video, give us a like and subscribe my channel. Thank you.